Okay, great. So, first off, a massive thanks to everyone for joining today. Having your time is really much appreciated. So, today we're going to be looking in some detail at how we can build the best highly available paper cut solution. We're going to cover why it's important to have high availability and what we need to achieve it. Then we're going to show you how it's done. I'm Roman Humphreys. I'm a business development manager here at Loadbalancer.org, and I'm going to be one of your hosts for today, alongside Rob Congalton, solutions architect.
Hello.
We've also got two very special guests with us. We've got Doc Ballje, PaperCut subject matter expert.
Thanks, Roman. It's great to be here.
Fantastic to have you with us, Doc. And Immanuel Bilson-Graham, a solutions architect from PaperCut.
Hi, everyone. Great to be here too.
Amazing. Thanks for joining today, Immanuel. So on the agenda for today, we've got a few things to talk about. We're going to go over a bit of a back history of print with Doc and just kind of look about how we've got to where we are today. We're going to talk about the challenges of high availability and what kind of causes downtime. So downtime is kind of, we talk about it a lot in the load balancing space, but sometimes we forget we need to highlight actually what causes it. So what are some of the things that are going to cause the servers to fall over that's hosting our applications? And then we're going to cover what we're going to need in order to get started at building out this highly available solution. Then we're going to hand over to Rob, and he's going to show us, once we've got all of these bits, how we can set it up. And then we'll have a few closing points and time for a Q&A. So on the Q&A, there is a chat box in here in the room, which basically, as we go, just drop in any questions that you have, and what we'll do, we'll get to them at the end and just try and get through as many as we can, really. Now, the approach to building a solution requires some thought. You need to make sure that it's not going to break, particularly in healthcare, education, or legal and finance, but many other industries too. Printing is mission critical. So it's very important to think about what happens, or what would happen to the organization that you're building your solution for if what you're building for them were to become unreachable. So this is why we want to build in high availability. It's that safety net to say that if the servers that the applications are running on were to fail or become unreachable, we have an automatic switch to something that is working. This is where we've put in the work with PaperCut. So when we're looking at load balancing, factors such as existing workload or supported load balancing methods can play into whether or not you've got a working solution. We've seen a number of cases where we've replaced load balancers that have failed to work because they don't have the required load balancing algorithms for the applications that are trying to be made highly available. And there's also a very real risk that you'll impact other services in the network by integrating with an existing load balancer, potentially a resource battle, so to speak, with new services being added, competing. You could even misconfigure and bring something down, which is obviously the worst outcome you could really want when implementing something. So with all this in mind, we worked with PaperCut and their ASC network to create a fully documented, supported, and working solution. So Doc, what I'll do now is hand over to you to get us started with a little bit of a backstory on printing.
Yeah. Thanks, Roman. I've been involved in the printing and imaging industry for over 20 years now. And I've seen a lot of the development of print drivers and printers themselves being, like the copier itself started as just a copier, but then they realized that, oh my goodness, there's a scanner. So we could scan a page and we could actually then send it off as a digital type of form or something. And if we put a board in there that can handle some software, we could actually print to a device as well. And so things really started blossoming and, getting things printing. The first dot matrix printer was actually in 1968. And the first laser printer came out in 1969, which is kind of amazing to think about because we really didn't have personal PCs until mid '80s or so. The Apple laser writer came out, kind of changed the world, and was enabled people to do like desktop printing. So it's like, well, why are we talking about high available printing? What's the problem? The problem is people don't know about printing. It's not really been in any Microsoft course or Mac course or Linux course. They don't really talk a lot about printing. And you open up a print driver in Windows, and you've got things like, print processors. What the heck are those? I find that I can set default printing things in two places in the driver. What does that mean? What's RAW? What's LPD? Nobody really talks about these things until something happens. Like recently, we had this print nightmare that's been going on. I think it's finally patched after about 2 or 3 patches from Microsoft. But see, the printing part of things is so unknown that this happened where they found out you could actually take over some control and take over some servers that way. So now that's patched, and everything should be good. But it just brings into light everything that we need to think about with printing, because a lot of people don't know about printing. And Roman, as you mentioned, there's industries that are very important, very paper intensive. They need to be able to print to have things happen. Financial type of institutions and hospitals, universities, as we're talking about. So that's kind of how we got there. And of course, people are like, well, aren't we paperless? It's all computer driven. It's the paperless office. And the funny thing is, we're actually generating more paper than being a digital thing, because more devices are printing. People are printing from smartphones and tablets and mobile devices, and printing from cafeterias and coffee shops and things like that. So people still need to print today, because they need to get information on paper for someone else, or whatever the case may be. So it's important, and that's the kind of the history of it. We just need to make sure that we can. A lot of companies need to make sure that they have to are able to print at all times. So this kind of brings into the discussion of what happened. Why do things go down? What happens to where we can't print? And I'm going to throw it over to a couple of the experts here, Rob and Immanuel, to kind of talk about some of those causes of downtime, why we might need a high availability system.
Okay, so in our experience, the cause of the downtime, first one, server failure due to hardware or software failure. So load balancer would see a failed health check and send traffic to a healthy server. Second one, servers overloaded and unresponsive. So you've got many applications running on there, many clients accessing them. We would see unresponsive servers and route to a fallback server if necessary, or route to another healthy server. And then there's server network failure. Someone pulled the wrong Cat5 cable at the MDF. We detect failure and forward to traffic to a healthy one. And then there's application. Now, PaperCut is a solid application. However, in the unlikely failure, we health check the application layer, not the port. So we detect this and move on to the secondary server.
So we're talking high availability in these types of organizations, and there's a lot when we talk about high availability. But I don't know. I'm just thinking, can I just have a VM? I mean, VMs are very present. Can't I just have another VM ready just to turn on? I mean, isn't that possible?
Yeah, you can do that, and you can bring it up manually, and you can change the DNS record. And if it's in the middle of the night, then either you're on call or your user wait for you to get up and do the changes. So there are other ways, and you can automate this, possibly an alarm, but effectively you're building yourself another HA system, or trying to. However, with the PaperCut HA system and the load balancer solution, if the PaperCut app server fails and falls over to the other server, the health checks will pick this up, and the service is available on a different server and route accordingly and automatically. And you'll get an update from an email alert per virtual service, or an SNMP update on the service failure, whichever way you want to configure it.
So what you're saying,
Gotcha.
Rob, really is that having a load balancer just gives you peace of mind, where you don't, and requires less user interaction for when a failure occurs.
It takes away that level of fear that IT departments have, and corporations and heads of department, that level of fear that something's going to go pop in the night and they won't know, and it won't be sorted out automatically.
I'm also hearing a lot of time involved, just with a VM and changing all the, the DNS records and getting all that done. So that might not be a viable solution for somebody that needs, a hospital. I need to print a discharge paper for somebody, and I've got to wait for something like this to get done, and now they're getting backed up because we've got a lot of activity in the hospitals all over the world right now, and we need to get people in and out, printing wristbands and that type of thing. So let's just say we're in a situation where, printing is mission critical for my organization, and I want to get this going. Emmanuel, we were talking about PaperCut, and I guess I want to ask about, there's this new in-app type of service that's available with PaperCut. Can you give us a little explanation of what we need to have going on the PaperCut side to get high availability going?
Sure. So as of version 20 and later, within the PaperCut NG and MF software stack, you now have the ability to configure it within an active passive high available configuration. So the prerequisites for this are simply PaperCut, more than one server, shared storage, an external database, so that all servers can communicate off the same data, and ultimately a network load balancer. With those things, you'll be capable of creating a highly available instance. And the great thing about this is that this could be more than say two servers, for example. So you could have an active application server, and then you can have a passive one at another site and another passive one, and so on and so forth, depending on your network setup. And the architecture is very flexible in that approach. Now, just to add, in terms of how we go about this, PaperCut have got a detailed guide on how to walk through those steps. And obviously, we do provide support if you do have any questions with regards to how to go about that.
Now, in PaperCut, of course, we're talking the application server and all that. So we're protecting everything, but there's a lot of other features that are available in PaperCut too. So is this going to work for things like print deploy, or even find me? Is that going to still work effectively? Secure print will have all of those features available. Is there anything else we need to really be concerned with, or that's going to do it for us?
So in terms of, say, print deploy and find me and secure print, because those features are actually part and parcel of the application server stack, as long as you have an application server that is alive and kicking, those features will continue to be available. They're not separated out individually, so therefore, as long as your application server is online, those features would also be online as well.
Cool. So we still have a complete print management system, high availability, and we do that by using a network load balancer, which is great because we're here at Loadbalancer.org. And we could talk more about how this exactly happens. So Roman, I'm going to send this back to you to kind of help us out on what the load balancer does and how we set it up and all that kind of good stuff.
Yeah, exactly right. So I'll talk a little bit before handing over to Rob, because ultimately he's the man who knows all this much greater level of detail than I do. But yeah, just to really just cap off what we've said there. So basically, PaperCut version 20, what is essentially the main brain of the application, now does support a failover to a secondary appliance. Now, what you need to do in order to achieve that is have a load balancer in front to basically manage the network traffic when that does happen. So again, what we've done is we've worked with PaperCut and the ASC network. We've tested, labbed out, pulled apart, documented all sorts with the appliance and the applications, and kind of find ourselves where we are today, which is a working solution that just complements PaperCut exceptionally well. So what I'll do, I'll hand over to Rob, who can basically just show us around the appliance and actually how we set this up.
So prerequisites for the load balancer. We normally ask customers to have a pair of HA. They're in active passive mode. So the active will be accepting the traffic. The passive will be always listening and accepting changes if there are any. We are on hardware and virtual. So my demonstration today will be on VMware. The method we use for connection back to the PaperCut app servers, we prefer using layer 4 DR. It's fast, it's simple, and it's source IP transparent, and that's probably the most important part. So direct routing, direct server return, is the only transparent load balancing technique that doesn't require the default gateway to point at the load balancer. It does go by many names: DSR, direct routing, LVS, DR, and NPath. If you have an F5, you may recognize it. So Loadbalancer.org has been contributing to the LVS project for the last 15 years, and it is our preferred method of load balancing. The traffic flow is very simple. The client can send a small request through the load balancer, which is sent to the PaperCut server, which directly responds to the client, bypassing the load balancer, meaning an extremely fast response. So normally this would break the TCP freeway handshake. So we have to make minor changes to the real server's weak host model to ensure that they respond with the virtual IP as well as their own address. So the advantages of DR are full transparency. The servers can see the connection directly from the client IP and reply to the client through the normal gateway. MFDs, particularly, we've identified as needing source IP transparency in this fashion. And also, no infrastructure changes required. The load balancer must be in the same subnet as the backend servers. That's the one requirement we do have. And it's lightning fast. Only the destination MAC address of the packets is changed. The disadvantages of DR: the backend server must respond with its own IP for health checks and the virtual IP. So we do have to make changes to the backend server. So in some cases, you're not going to have access to your backend servers. That might be out of your remit. In that case, if you can't get them in the same subnet, if you can't make changes on the backend servers, we have other methods, such as layer 4 SNAT and layer 7 proxy SNAT. So there are methods. But today, going to be showing off layer 4 DR. Okay, our first VIP that we're going to add, we can go to cluster configuration, layer 4 virtual services, add a new virtual service. And this is going to be our PaperCut. It's our app server, where we're going for the web UI. And I'm going to give this a floating IP address, 192.168.75.40. And the ports we care about: 9191, 9192, and 9193. TCP, and we are layer 4 DR. Okay, all looks good. And we click update. And we have a bit of information at the top. With the current configuration, port must be set for real service health check. The default check port 9191 has been chosen. Now we're going to come back and change that later on, because there is a specific health check for the layer 4 PaperCut app server. But we're going to continue on and add some real servers. So the backend server will make this app server number 1. And this is 192.168.75.81. And update. And we're going to add the secondary server, app server 2, 192.168.75.82 update. And we've got these open up here. There's 81 and there's number 82, and you can see they're in HA mode. They're actually talking to each other because the secondary server is activated and it's only in monitoring mode. So these are the real servers we've just added into the back. Go to overview. Okay, so this is our first, and we can see that they're both up, but that's not very good. We're going to come back to that and deal with it in a moment.
So there's one question I have at this point, Rob. Now, under cluster configuration, we've got two options for VIP configuration. One's layer 4 and one's layer 7. Why have we chose layer 4?
Good question. So for print, raw throughput is the primary concern, and layer 4 wins over layer 7, as layer 7 is a proxy. Also, we're able to achieve source IP transparency with layer 4 DR, which is a little harder to do at layer 7. So layer 4 is where our protocols for print reside, and this is where we should really care about it. So continuing on, let's add another VIP, add a new virtual service, and now we're going to do the print provider. So let's call this PaperCut print, and 192. I'm going to give this a different virtual IP, and each one of these virtual IPs, as I introduce them, they create a floating IP address which sticks to the load balancer that is active, and if the load balancer switches over to the secondary node, the backup node, which we've got here, then that floating IP will go with it. So this IP, if we fail over to the other appliance, then this will follow as well. So we're going to click update, and then we're going to add a print server, and I'll call this print 1, and this is 192.168.75.3. That's my print server, and I'm going to click update. Okay. Now I'm going to go back into layer 4 virtual service. I'm going to modify that last VIP. I'm going to modify that last VIP. And here we're going to remove persistence. So we don't use persistence for print at layer 4, as it may present performance issues if we try and introduce sticky connections. Disable it for print if you can, please. And also note that we are on health checks connector port. So we're connecting to port 445. Update. Okay, and let's put in the last VIP. I'm going to do mobility print. Mobility. And we're going to give this the same IP, the same floating IP as the print VIP, and the ports are 53, 4163, 9163 and 9164, and it's going to be a combination of UDP and TCP because we're going to be using a bit of DNS here with port 53. Still layer 4 DR. Update. And then I'm going to go back to real servers, add a real server, and I'm going to call this print 1 and 192.168.75.3 for the print server. update. And if we go back to layer 4 services and modify the VIP we just put in, first of all, we're going to take away persistence. And then connect to port. It's trying to do a connect to port on port 53, and we can't have that because that's DNS. So we're going to put in 9193 as the documentation specifies. So that'll do a port check on port 9193. And now we go to system overview, and we are green across the board. However, the PaperCut web UI, the app servers are in HA mode, and they're both responding, and we know that's not the case. We know that in HA only one server should be responding. Let's go direct to them. Here's me going direct to the backend servers on port 9191. App server 1 is responding, but app server 2, it's answering the port 9191 and the health check, but we're still seeing it. We can't actually direct traffic to it because it's not available. So how do we deal with that? If we go back to edit the web UI, first of all, take off persistence. We said we don't need that. But here we've got a health check, and we can do something special. We can negotiate on port 9191 HTTP request to send. Now, if we can log into the PaperCut application server, we will be able to find something unique to the installed services. If we go to options and then advanced, we'll be able to find this query parameter. So we have a parameter here, API/health, and an API key. We can copy this and then go back to our configuration of the load balancer and paste it in here. And what that's going to do is actually ask the servers, will they respond to this authorization key? And the response should be okay. Click update. Now let's see what that's going to do to our configuration. So that's saved. I can go back to system overview. And there we go. We've naturally lost one of our servers, but what's happening is we are throwing a health check at it, asking it, do you have this key? Are you able to respond to this API key? And the active appliance is saying yes, but the passive, the standby one, is saying no. So it's responding on 9191, but it's not able to respond to our request on this key. What does that look like in real life? What we haven't tested is the VIP. So now we can go in 192.168.75.40. Now this is the floating IP here. This is our head end. Let's see what happens when we go in on that new VIP. Straight in. What does that look like? Couple of connections. Good. Now let's log in. Admin, our password, and now we are going via the load balancer. Couple of connections there. So what happens when this fails? I can go over to the servers and I can actually stop the application on application server 1. So I'm going to stop this. I'm going to put in my password and it will stop now.
So while we wait for the secondary PaperCut application server to spot this and take over, you've used the term health check a lot. can you elaborate a little bit on what a health check actually is?
Okay, so health checks are crucial to load balancing. Health check is one of the ways the load balancer measures the availability of a back-end server, checking if the port is open or the database table is available, or if a specific web page is being served up by the server. So for the print servers, we did a port check, TCP 445 for the print servers, and that's good enough. But it's not good enough for the app servers. So with the app servers, in normal service, both app servers are up and responding on port 9191. However, only one is actually processing requests. We can check which one is active with the HTTP negotiate check, asking each server if they can respond to the correct API key. This method allows us to load balance traffic only to the healthy in-service application. In this case, we are worried about picking up a healthy server rather than load balancing across multiple servers. And any minute now, we should see app 2 come back. Now, does it work? Here we are in a VIP. If I hit, okay, we're back in, admin. And now we are on application server 2, and here are our connections. And that's high availability on PaperCut.
Rob, thank you very much for showing us how to set up the load balancer. A really great run through. What you've just seen, we'd class as a standard setup. We're not doing anything too complex. As Rob mentioned, there are other options that we have, including multi-site, where we can use GSLB if you're working on a deployment over different geographic locations. So I just wanted to spend a moment talking about how this is all going to help and recap some of what was mentioned at the beginning. So using load balancers is about removing risk, but also adding scalability too, as that's another really massive consideration. So how can you support an organization's growth effectively? You can do things like adding additional servers into the cluster quite seamlessly if more resources are required. So these are all things to kind of have a think about. Something also is security. So our load balancer has features such as a built-in web application with firewall and DDoS mitigation, which can really help just adding that extra layer of protection. Load balancing solutions built on open source for technology vendors and IT teams. We give you the flexibility that you need to future-proof your solutions and environments so that load balancing will never be a problem again. Our product, quite like PaperCut, is very user-friendly, and I hope that after today's session, you will have all seen that. But it's also very powerful too. And again, we've only had a limited amount of time today, so really what we've shown is kind of just the tip of the iceberg. We've also got a very future-friendly licensing model, which makes us a great long-term financial solution. So things like the Freedom license, which does allow flexibility when migrating from platform to flat platform. And again, where the load balancer looks the same across hardware, virtual, and cloud, from a user perspective, from a technical perspective, it's a very easy transition. So where do we go from here? Well, what we'd love is for you to take what you've seen today and try it for yourselves. So we have trial appliances that are available for download, so you can set up a virtual load balancer in your own labs or even a prospective customer's site if you're running a POC. And we'll provide you with the documentation as well, which will go through the steps on how you can set up the load balancers with PaperCut. So what I'd say is speak with us and your ASC about any customer projects that you have or have had in the past, because again, this is something that can be deployed with an existing PaperCut environment. So it doesn't have to go in at the beginning. So yeah, download the trial, use the documentation, speak with your ASC and us, get some labs set up, have a test for yourself, and then any questions like that, or maybe how to use it. If you've got sites that you think might be a good fit, then speak to us and we'll help you take it from there, really. So what we'll do now is switch over to our Q&A. Okay, so we've got a few questions come in. I think this one's going to be for you, Immanuel. Any impact for integrated scanning performance, seeing as that all goes through the application server?
Sure thing. Can everyone hear me okay?
Yeah, we can hear you.
Yeah,
Brilliant. Okay, so performance shouldn't be affected provided that the load balancer is configured correctly. The network bandwidth is available and throughput is sufficient. Essentially, if you using Rob's suggested deployment of layer 4 direct routing, essentially means that you'll have fast throughput, because when you make a request, so you're the client, you make a request to do the scan, that request goes to through the NLB, and the reply from the server goes direct to the client, and therefore you have fast throughput. So no impact should be experienced.
awesome. Thank you very much, Immanuel. Did anyone else have anything to add to that?
No, I can just concur. This is Rob. Layer 4 DR is the much preferred method for stuff like this, just on print and on the medical imaging. It's the fast throughput that we really desire. So it's a really good, simple method to use.
Awesome. Thanks, guys. So going to answer a couple of questions in one here. So we've had a few just about NFR licenses and getting set up for yourselves. So we'll get you the links to download the trial virtual appliance, which you can deploy in your own labs, and then we'll help you get those demo rooms set up and working for with test licenses and things like that. So yes is the answer to can we help you all set up in your demo rooms. Okay, there's another one here that I think Rob is probably for you. TCP port 445 health check is SMB, but if the print spooler had crashed, this wouldn't be picked up by the load balancer. Correct.
Yeah, that's a great point. And we do have a blog on this written by Immanuel. He did a health check, what was his time with load balancer. And it's actually interrogating the Windows system using WMIC and actually looking to see what services are running in the back end. So we do have that. However, my friend there, Immanuel, did actually warn us that the link to the download for using the WMIC plugin to the load balancer is deprecated. We've got a new link and we're going to update that blog today. So yep, I've posted the link in the chat. You can check that for yourself and have a look through it.
Great stuff. I think the link's in the chat, but we can't see it. So we'll make sure that link goes out. I've had one come in just talking about platforms. So the load balancer is available on hardware, virtual, and cloud. So the virtual appliance, as I think Rob mentioned earlier, is its own virtual machine, which you can deploy on, say, Hyper-V, VMware, Nutanix, and so on. We are also in AWS and Azure, so there are cloud appliances also. There's another one come in as well. If a customer would like to trial this, how long can they trial for, and how many extensions could they be given? So yes, the customer could trial it. So the VM, the virtual trial download is 30 days with the full appliance. So we can use that for any proof of concepts that you're running. And if they're kind of going to go over the 30 days, then on a case-by-case basis, we can look at what extensions are going to be required. Okay, maybe Rob, so what about Azure AWS with their own high availability? How does it compare? Rob, did you want to take in on any of that?
Yeah, AWS, we do have services there, proper high availability, much like you see from the demo we were watching there. On Azure, it's a different ball game in that we have to use the Azure's load balancer in front to help us with health checks. It's just the way that Azure is built and built around the concept of their VPCs. The other issue is we have problems with high availability source IP transparency in Azure. So that really does need some consultation with us if you are in Azure and thinking of doing this.
Awesome, thanks, Rob. I can see another one in there saying, will we get a copy of the recording sent to us? Yes, you will. So we will share the recording from today's session after, afterwards. Rob, potentially another one for you. If the customer insists on layer 7, what changes are required on the print servers, i.e. are the reg edits still required?
Yeah, they're required all the way up to 2016. I was looking at this the other day, but oh no, 2018, something term was 2016, but on 2019, the reg edits aren't required for the print servers. We do have a blog on that and we can forward that in the chat. I'll find that and forward that on.
So thanks, Rob. Okay, that looks, if anyone had any other, I mean, that's all the questions we've got in answered at the moment. Does anyone else want to chuck something in real quickly? Obviously, we're available for follow-up conversations if there was anything else that we kind of wanted to see. Oh, there's a few more coming now. Do you have to create rules for authentication, such as LDAP and card readers?
Sorry, if that's to the load balancer, then we are direct throughput, transparent, so we don't have to do any part of that. There's no setup from us.
Okay, another one here. There's any way to only have one print server responding instead of 2 print servers being alone? Oh, sorry, online. I know the print job only goes to only one print server.
Yeah, you can do that with a fallback server. So the VIP that I was showing, you could have, instead of 2 print servers serving up jobs, you'd have the one print server, and then we have a section called fallback server, and you just put the IP address of your other server there, and it would overflow when the first server fails.
Fantastic, thanks, Rob. Okay, I think that covers every question we've got, and probably draws us to a bit of a close. So if you didn't get your...
Hold up. He's come.
Yeah.
Sorry, Roman, he's come back. Yes, can I just clarify? That only means one server will be online to Daniel. Okay, so only one server will be online and you overflow to the second server. Okay, no problem. And just to clarify on the print server registry changes, it's only for Windows 2012 and 2016. 2019 needs subtle changes, but it's in the setup guide, which we will send along with this.
Fantastic. Maybe one for you, Immanuel. What would be a realistic expectation to set on the delay between switching to failed app server to the passive node?
Well, in the configuration of the application server HA, we have a default setting of 30 seconds where both app servers will communicate with the database and claim which one is the live and active server. So by default, we say 30 seconds. However, obviously, you've got to then include the fact that the load balancer will send a number of health checks. Let's say in this instance, it could be 2 to 3 health checks every 4 seconds. Well, let's say 5 seconds to make it easier. So add 15 seconds on top. So in theory, it would probably anywhere be up to about a minute and a half. It could be quicker than that, but those are the expectations that I would set. And to be fair, I don't think the impact of the application server failing over within that sort of time frame would adversely affect a lot of your users, as long as you're aware of that expectation.
Fantastic. And I think that's, but for the third time, I think that's everything answered. So we'll wrap it up there. Again, we're around to be sort of connected later on. So any questions that do come up, then we can obviously just open up another conversation, because what we've basically looked at is just kind of a standard deployment here. So we can talk about other which ways we can do. So yeah, basically to everyone that's joined today, a massive thank you. Seen a lot of familiar names there, so yeah, great to have you guys on here. And to our hosts, Rob, Immanuel, and Doc, massive thank you to all of you for doing this.
Thank you for having us.
Thank you.
Yes, thanks for having us.